You are standing in a workshop in Geauga County, Ohio, watching a man weld a steel frame using a rig powered entirely by compressed air generated from a windmill standing 40 feet behind his barn. The weld is clean, precise, and indistinguishable from anything produced in a fully electrified industrial shop. The man is wearing a flat-brimmed hat and suspenders. His workshop has no utility connection. His electric bill is zero. His productivity matches or exceeds comparable operations running on full grid power 2 miles down the road. Most people who think about the Amish think about horse-drawn buggies and oil lamps and a community frozen somewhere in the 19th century by religious conviction. That picture is not only incomplete, it is almost entirely wrong. The Amish relationship with technology is not a rejection of technology. It is the most deliberate, systematic evaluation of technology that exists anywhere in American culture, and the conclusions that evaluation has produced over 300 years have generated solutions to problems of energy, transportation, agriculture, and manufacturing that the mainstream world is only now beginning to understand it needed to solve. The Ordnung, the community governance framework that guides Amish technology decisions, does not ask whether a technology works. It asks what the technology does to the community that uses it. Does it create dependency on outside systems? Does it concentrate economic power outside the community? Does it weaken bonds between community members? A technology that works brilliantly but answers yes to those questions is rejected. A technology that seems primitive but answers no is adopted and refined indefinitely. The result is a technological ecosystem unlike anything else in the developed world. Here is the number that changes everything. The Amish population has doubled every 20 years for the past century. In 1920, there were approximately 8,000 Amish in North America. Today, there are over 370,000 across 32 states. This is not a community in decline or retreat. It is the fastest growing cultural group in North America by percentage, with a retention rate of approximately 85 to 90% of young adults who choose to remain after their rumspringa period of independent exploration. A community retaining 85 to 90% of its young adults in an era of full smartphone access is not a community people stay in out of ignorance. It is a community whose quality of life is measurably competitive with what the outside world offers, and the technology system that community has built is a significant part of why. The buggy is where most outside observers start and stop their analysis of Amish transportation, which means they miss almost everything interesting about how the Amish actually move people and goods. Modern Amish buggies manufactured in Holmes County, Ohio, and Lancaster County, Pennsylvania incorporate fiberglass body panels, hydraulic braking systems on all 4 wheels, LED safety lighting powered by sealed lead-acid batteries charged by wheel hub alternators, automotive-grade steel axles and bearings, tempered safety glass, and padded interior configurations. The Holmes County buggy manufacturing industry produces between 4,000 and 5,000 completed vehicles annually, employs hundreds of skilled craftspeople, and generates an estimated $40 million in annual revenue. It exports finished buggies to Amish communities across the continent. This is a manufacturing operation of genuine economic scale, building a product that produces 0 emissions per mile, requires no petroleum fuel, and carries a total cost of ownership dramatically below any motorized vehicle across a comparable service life. The standard-bred horses pulling those buggies are selected for temperament, endurance, and road behavior through a breeding and evaluation system operating across the community's farm network with systematic rigor. A well-selected standard-bred operates for 15 to 20 years of productive service, refuels on grass and hay the farm produces at essentially 0 purchased cost, and at the end of its working life, contributes its body mass to the farm's organic matter cycle. The fuel supply chain for an Amish transportation system is a field of grass. The fuel supply chain for an American transportation system is a global petroleum extraction and refining network worth trillions of dollars. The Amish chose the field of grass deliberately. The driver hiring system called using a taxi is where the transportation picture becomes economically sophisticated. Most Amish districts permit hiring non-Amish drivers for travel beyond practical buggy range. An Amish family needing to travel 80 miles to a specialist medical appointment calls a known driver, pays a per-mile rate, and arrives without having spent $30,000 on a vehicle, $2,000 a year on insurance, $1,500 on fuel, and $800 on maintenance. The economic logic is sound. The social logic is equally deliberate. A community without private vehicles does not develop the atomized mobility pattern of American suburban life, where the car makes it possible to live without meaningful proximity to neighbors or community. The driver system provides the mobility benefit of the car without the community fragmentation that private car ownership produces. The pneumatic power system is where Amish workshop technology diverges most dramatically from expectation, and where engineers who visit Holmes County manufacturing operations consistently report the greatest surprise. Because grid electricity creates utility dependency, placing the community's energy supply under external control, most Amish districts prohibit connection to the public grid. The prohibition is on grid connection, not on electrical or pneumatic power. Compressed air generated by gasoline, diesel, or wind-powered compressors is piped through workshop buildings to power pneumatic drills, saws, sanders, grinders, impact wrenches, spray systems, and conveyors. The system requires no grid connection, generates no utility bill, and delivers power comparable to electrically driven equipment at the point of use. The Holmes County furniture manufacturing cluster, producing an estimated $200 million in annual revenue from hardwood furniture sold across the United States, runs almost entirely on pneumatic and hydraulic power. This is a $200 million industry operating without utility electricity, producing work indistinguishable in quality from grid-powered facilities and competitive in price, with manufacturers paying full commercial electricity rates. Hydraulic power generated by gasoline engines or water wheels powers equipment requiring higher force output than pneumatic systems efficiently deliver. Hydraulic wood splitters, presses, lifts, and conveyors operate in Amish workshops and farm buildings across Ohio and Pennsylvania without any grid connection. The sophistication of these systems surprises visitors expecting primitive hand tools and finding instead integrated pneumatic and hydraulic infrastructure of genuine industrial capability. The battery and inverter system represents the most rapidly evolving component of Amish technological infrastructure. 12-volt DC systems powered by lead-acid or lithium batteries, charged by solar panels, wind turbines, or small generators are permitted in many districts for lighting, communication equipment, refrigeration, and small power tools. The 12-volt limitation reflects a deliberate choice to operate below the voltage threshold where grid-equivalent power becomes available, and with it, the full range of appliances and entertainment technology the community has evaluated and declined. A 12-volt system powers LED lighting, a converted chest freezer, a two-way radio for business communication, and tool chargers. It does not power a television, a desktop computer, or any of the entertainment technologies that Amish community evaluation has identified as corrosive to family and community cohesion. Dr. Donald Crable, a sociologist at Elizabethtown College in Pennsylvania who has spent 40 years studying Amish society and authored multiple peer-reviewed academic works on Amish technology and culture, describes the Amish technology evaluation process as a form of collective technological discernment that has no equivalent in mainstream American culture. In mainstream culture, Crable observes, technology adoption is driven by individual preference, marketing influence, and peer comparison, with community-level consequences evaluated only after the technology is already embedded in social practice. In Amish culture, technology is evaluated at the community level before adoption, with community-level consequences as the primary criterion. The result is a community that has avoided the social fragmentation, economic dependency, and attention capture that have accompanied technology adoption in mainstream American culture while retaining access to the productivity benefits of technologies that pass its evaluation criteria. The solar adoption curve in Amish communities illustrates Crable's framework in real time. In the 1980s and 1990s, photovoltaic technology was largely rejected because available panel sizes and battery systems were insufficient to support 12-volt DC applications adequately. As panel efficiency improved and battery technology advanced through the 2000s and 2010s, solar adoption accelerated across Ohio, Pennsylvania, and Indiana, in applications remaining within the 12-volt DC framework. By 2020, solar panel installation on Amish barn and workshop rooftops had become common enough in Holmes County that aerial photography shows a landscape more progressive in solar infrastructure than many suburban American neighborhoods, whose residents have not made the same adoption decision, despite having access to far greater financing resources. The farm machinery system represents a technological ecosystem of extraordinary sophistication operating almost entirely outside mainstream agricultural awareness. Steel-wheeled tractors, permitted in many districts for stationary power takeoff applications running grain augers, feed mixers, and silage choppers, are configured specifically to prevent road travel by design, rather than rule alone. The steel wheel configuration that makes these tractors unsuitable for road use at speed is a deliberate engineering choice that physically embeds the district's technology boundary into the equipment itself. The machine's own design enforces the community's decision about what the machine is for. This is technology design as community governance, an integration of values into engineering specifications that mainstream technology culture achieves accidentally at best, and never intentionally. Horse-drawn equipment manufactured in Lancaster and Holmes counties has evolved continuously across the 20th and 21st centuries in ways largely invisible to outside observers, because the power source remained constant while the implement's mechanical sophistication increased dramatically. Modern Amish horse-drawn planters are precision seeding machines with adjustable row spacing, seed rate calibration, fertilizer application systems, and depth control features equivalent in agronomic sophistication to GPS-guided precision planters used in mainstream commercial agriculture, minus the GPS and the $400,000 price tag. When a component fails at planting time, repair happens in hours in the farmer's own shop. When the GPS guidance system on a $400,000 precision planter fails, the dealer's technician arrives when the dealer's schedule permits. The repair culture that Amish technology generates is itself a form of resilience that the mainstream technology system has systematically eliminated. When every tool and machine is designed to be repaired rather than replaced, when the skills for that repair are distributed across the community rather than concentrated in credentialed specialists, and when the economic incentive to design unrepairable products is absent because the community does not purchase from manufacturers producing them, the result is a material culture with a fundamentally different relationship to obsolescence. An Amish farm has equipment from multiple decades of manufacture in active production use simultaneously. Nothing is retired because a manufacturer released a new model. Things are retired when genuinely worn out, which in a repair culture occurs on a timeline measured in decades rather than the product replacement cycles that consumer technology markets require. The communication technology picture is perhaps the most widely misunderstood aspect of Amish technological life. Community telephone shanties, small outbuildings positioned at property lines and shared by multiple households have been standard in many districts since the early 20th century. The phone is available, it is not in the house, it is not in the pocket. It is not a device whose presence in every waking moment creates the attention capture, social comparison, and erosion of present-moment community engagement that smartphone adoption has produced in mainstream culture. The Amish did not need a decade of social media research to predict these outcomes. Their technology evaluation framework identified the risk before adoption and positioned the phone appropriately. In more progressive districts, cell phones for business use are permitted but restricted to shop locations. The boundary between business communication tool and personal attention capture device is enforced by location rather than by willpower, which is a more structurally honest approach than the screen time management apps that mainstream culture developed to address addictive technology design after the fact. The water system engineering across Amish farms demonstrates another dimension of technological sophistication that most outside observers never encounter. Ram pumps, hydraulic devices that use the momentum of flowing water to pump a portion of that flow to elevation without any external power input, operate on farms across Lancaster and Holmes counties, wherever adequate stream resources exist. The physics was described by John Whitehurst in 1775 and refined by the Montgolfier brothers in 1797. The device has no moving parts beyond 2 check valves and requires no fuel, no electricity, and no maintenance beyond periodic valve inspection. An Amish farm with a ram pump delivers pressurized water to barn and household systems without any ongoing energy cost or utility dependency. The technology is 250 years old and is in active, productive use on farms that also incorporate solar panels, precision pneumatic machinery, and hydraulic workshop equipment. The Amish do not select for old technology or new technology. They select for technology that works without creating dependency, and the age of the technology is irrelevant to that evaluation. The woodworking and furniture manufacturing technology operating in Holmes County represents what happens when skilled craft production is optimized over generations without being disrupted by industrial replacement. Holmes County furniture shops run pneumatic tools across operations of genuine industrial scale, producing products commanding premium prices in mainstream retail, specifically because their quality is demonstrably superior to factory-produced alternatives. The market is paying for the consequence of generational skill accumulation in a craft tradition never interrupted by the de-skilling that accompanied industrial production in mainstream manufacturing. A Holmes County furniture maker in his 40s learned his trade from a father who learned from a grandfather in an unbroken chain of skill transmission going back to European workshop traditions carried to Ohio in the early 19th century. That chain of transmission produces quality not replicable by training programs, not purchasable by capital investment, and not manufacturable by automation. What the mainstream world is beginning to understand, through the lens of supply chain fragility exposed by the disruptions of the last several years, through the growing literature on technology's social consequences, and through accelerating interest in energy independence and local food production, is that the Amish technological evaluation framework anticipated problems that mainstream technological culture is only now recognizing it has. A community whose energy system cannot be disrupted by grid failure, whose food system cannot be disrupted by supply chain failure, whose transportation system does not depend on petroleum or electronic infrastructure, whose communication system does not expose its members to the attention capture economy, and whose manufacturing capabilities are distributed across the community rather than concentrated in facilities dependent on global logistics, is a community whose resilience profile is structurally superior to mainstream American communities in ways that no amount of emergency preparedness planning can replicate without the underlying technology choices that produce that resilience organically. The man in the Geauga County workshop finishes his weld, lifts his helmet, and examines the joint with the critical attention that any skilled welder brings to quality evaluation. The weld is sound. The compressed air compressor behind the barn cycles down. The windmill above it continues turning. The workshop has produced what it set out to produce using power from the wind, skills from 3 generations of family practice, and technology evaluated not by whether it impresses, but by whether it serves. That is the Amish technological standard. It has been applied consistently for 300 years. It has produced a community that doubles in population every 20 years, retains 85 to 90% of its young adults, generates hundreds of millions of dollars in manufacturing revenue without utility electricity, feeds itself through winter without supply chain dependency, and repairs rather than replaces everything it owns. The mainstream technological world spent the same 300 years building something faster, something more connected, something more impressive, and something that fails completely when the power goes out. The Geauga County workshop kept running through the last 3 grid outages that shut down every electrically dependent business in the county. The windmill did not notice. Drop your state in the comments and tell me which piece of Amish technology surprised you most, because the pneumatic workshop system, the precision horse-drawn equipment, and the ram pump consistently land hardest for people who came in expecting to see the 19th century and discovered something that looks, on its own terms and by its own evaluation criteria, considerably more like the future than what replaced it.